All right, so this is continuing with our examples of the binomial. So our next example, I suggested that you try this one on your own. So what I've done here is I've shown the example worked in its entirety. So I started out with p hat and its complement q hat. Then I found alpha. Then I found alpha over 2, which I used to get my critical value based upon the area under the curve of being 0.025. Remember, I can look this up in my t-table at the large degrees of freedom with 0.025 in one tail or 0.05 in two tails, or I can use my z-table, or I could use my calculator and do the inverse normal. Note that when you do it on your calculator, you will get 1.9599 something or other like that, and that value approximates to 2 decimal places to 1.96. So we put those values into our margin of error calculation. The z, the critical value, 1.96 times the root of p hat times q hat divided by the sample size. And that gives us an approximate value of 0.046743. And then I'm going to create my interval by taking my p hat, my sample proportion, and adding or subtracting that margin of error of 0.0467. I take it one more decimal out than what I'll need. 3 decimal places is appropriate, so I take it out one more, and then I'll round appropriately to 3 decimal places. So my true population proportion I believe to be between 30.3% and 39.7% with 95% confidence. All right, now the last thing that we want to do is similar to what we did in our first section of the chapter, where we were finding sample size. If we were to do a survey or to go out and collect information on our own. So if we were starting with a survey that had been kind of like to find out basic information about how much or what's going on out there, we may have sample proportions already, and if that's true, then we would use p hat and q hat. However, if we had done nothing, we would assume that p hat is equal to q hat is equal to 0.5, and when it's a 50-50, that means that these end up looking like p hat times q hat, which is equal to 0.25, and that's what you would use in the instance that you didn't have any idea what p hat and q hat might be. You just assume that it's an equal 50-50 shot. So what I've done here is I've shown you the taking the margin of error computation, the formula, and working it backwards to get the sample size. So what you see is p hat q hat multiplied by z over e quantity squared, or as you see over on this side of my in my notes, we have z squared over e squared and then times p hat q hat, and it doesn't matter, it's just the same formula. So now we're going to go ahead and do an example using this to find sample size. So here is my problem. It says if clients want a 90% confidence level and a margin of error equal to 0.2, calculate the sample size that is needed to a certain 90% confidence is achieved if a previous poll showed the p hat was 0.47. So my p hat 0.47, and that means of course q hat, which is 1 minus that, would be 0.53, and my sample size this time, this is what I want to know, right? And my confidence is alpha is 1 minus 90%, or 0.1, and so my alpha over 2 is 0.05, and that means that I'm putting 0.05 over here and 0.05 over here, and that I'm looking up using an inverse normal the z that gives me a 0.05 in the left tail, and therefore my critical value, my z alpha over 2 here, this is going to give me a 1.645. Now remember that you can use your calculator, you could use a z-table, you could use a t-table, but no matter which one you're going to use, you're going to end up with this 1.645. Remember, this is the one that is right there. We see 0.05 in one tail, 0.1 1 in both of the tails, and that's the value we were looking at. Now, our margin of error in this case has also been told to us, and the margin of error that we're looking at is going to be within 0.2 of the true population proportion. So if it doesn't say margin of error per se, what you're looking for is how close you want to be to the true population proportion, and that is what margin of error is really talking about. So I have my z 1.645 up here, and my margin of error, my 0.2 down here. I have my p hat 0.47 and my q hat 0.53. Now I just put it like that because I hadn't left myself enough room, but I'm multiplying all these three values out. And remember, you could square the z and square the margin of error. Right, that's another way of doing it and doing that calculation. I'm going to do 1.645 divided by 0.2, and then I'm going to square that value, and I'm going to multiply it by 0.47, and then I'm going to multiply it by 0.53. And that gives me 16.8517. 8517. And remember, I always want to have a little bit extra, so I'll always go up no matter what. So I'd want to have a sample size of at least 17. Okay, now that I think was it. Yes, and so our next sections in this chapter are going to be about estimating differences between means and proportions. And so this time we'll be talking about having two samples instead of just one sample. And I also throw into my discussion on confidence intervals for the standard deviation as well. So we'll talk about all of those later. But I'm going to bundle all these videos right now and call it good for the time being.